I will start with an introduction on why geolocation matters in IoT, and specifically in massive IoT, which is the main target of Sigfox. We'll have then an overview of the geolocation technologies which are available for asset tracking solutions before going in depth on the Atlas suite portfolio. So we'll have an overview of what is Atlas, an overview of the portfolio of Atlas Suite, which is composed by different services, from Atlas Native to Atlas Bubble. Last but not least, before going in depth on the technology side, we'll have an overview of how to use Atlas concretely in your IoT solution. And then I will give the hand to Olivier Isson, which will go in depth on how it works. So how the Sigfox network location is computed, how we go from this network location to the service, which is Atlas Native, and then having an overview on how we improve our Atlas services thanks to machine learning. So first of all, let's have an introduction on why geolocation matters in IoT. So I really like this statement because it gives a good overview of the huge potential market of asset tracking in IoT. So every business and organization, regardless of size, industry, and location, has assets that need to be tracked and managed. It means that there is a huge market potential for IoT tracking solution all over the world and all over the verticals. More specifically, so this organization and companies need to track their assets for different type of needs. So some of them would like to avoid the loss of their assets. Others want to maximize their usage of their assets. And for example, McKinsey said that tracking each container using IoT technology could improve container usage. And some other customers would like to improve, for example, the customer satisfaction. So it gives you an overview of how IoT asset tracking solution can actually provide benefits and value to end customers, and how the geolocation services can help them to reach the ROI expected. We figured out then that IoT's tracking solution matter in two major domains. First of all, in the supply chain management. So we speak about supply chain logistics within all the value chain. So as you may know, in some industries, you have multiple sites and potential different stakeholders all over the value chain of the supply chain, which involves so different stakeholders, but also different type of environments. Can be indoor, so you need to track, for example, assets in indoor and both outdoor. It can be also overseas, so in a local, but also you would need an international solution to be operated everywhere. And in most of the case, you need to have both a connectivity and geolocation service in industrial and urban areas. The second main domain where the IoT tracking solution apply is asset and people recovery. So the need is to recover basically cars from beds to baggage, all types of assets basically, and people also all over the world. So we have, for example, a very famous use cases at Sigfox, which is the LVMH use case with the tracking of language, and all the use cases are coming also. For this type of use case, you need a tracking solution which can work both indoor and outdoor, which can work also everywhere in the planet, as the language are traveling everywhere. And compared to the supply chain management, there is strong expectations regarding the quality of service and the user experience with this kind of solution. So how do the geolocation service work on this kind of solution? So basically, everyone knows the GPS. GPS, which is the Global Position System, is a specific system, American one, which works quite very well in outdoor. So in outdoor areas, the GPS is very well known and works perfectly. However, in some other kind of environments, the GPS doesn't work very well. And that's why we use more and more the Wi-Fi. So Wi-Fi positioning is, I would say that the total cost of ownership is quite similar to the GPS. So the Wi-Fi module costs a bit less than the GPS, but you have to pay for Wi-Fi service if you want that it works. Compared to the GPS, you have not as good as accuracy as the GPS in outdoor. However, in indoor it works, and it works quite well because you have Wi-Fi hotspot in most public buildings and even private areas. And compared to the GPS, the battery consumption is quite low with the Wi-Fi. The third type of technology used also for asset tracking solution are the RTLS solutions. So RTLS means real-time location system, and it includes technologies such as RFID, ultra-wideband, Bluetooth technology, and it provides a very good indoor accuracy, especially for asset tracking in indoor environments. However, with this kind of solution, you need to set up a specific infrastructure in the basements and in buildings. So, and compared to the GPS, the reach, the outdoor reach is quite limited. And last but not least, LP1 geolocation. So since Sigfox and LoRaWAN started to develop their own geolocation technologies, LP1 geolocation is quite famous for IoT asset tracking solutions, because these technologies can provide a very quite cheap, well, there's differences between Sigfox and LoRaWAN location technologies. However, they are quite cheap, so the TCO is very low, and there is no impact on the battery consumption at all with this kind of technologies. However, due to the particularity of LP1 technologies, the indoor and outdoor accuracy is quite low. So this was to give you an overview of the technologies possible for asset tracking solutions. And at Sigfox, we choose to combine some technologies to actually provide relevant geolocation service depending on the use case. In this context, at Sigfox, so you will see the Atlas suite, we combine several types of technologies. So you can combine, you can actually include a GPS tracker in every Sigfox device. So it's a technology that is compatible with Sigfox, but is not included in our Atlas suite portfolio. You have the Sigfox, so it's the first one, the Sigfox network location. So as I said, it provides a low accuracy, but it's available quite everywhere, and it's a very low-cost solution. You have also, so it's for more indoor geolocation, so it can be quite similar to other RTLS solutions, the bubble. So the bubble that we announced last year, at the end of last year, which is a solution providing a very deep indoor accuracy. And in the middle, you have the Wi-Fi, which provides a quite good accuracy in both indoor and outdoor. So let's go now to discover what is Atlas and what Sigfox does provide as geolocation services. So you saw the geolocation technologies which are compatible with Sigfox and with Atlas. So there is Sigfox Wi-Fi, the bubble by Sigfox, which is an extension of the Sigfox network, and the GPS. Each technology has its advantage and disadvantage also. Regarding Atlas, the aim of Atlas is actually to provide and combine technologies to provide the right service to for the right use case. Atlas Native is based only on the Sigfox network location. Then we launched Atlas Wi-Fi, which is a combination between Wi-Fi positioning and Sigfox network location. And what we'll see tomorrow, so probably next year, is Atlas Bubble, which combine both Sigfox technologies, so the bubble by Sigfox and the Sigfox network location. All these geolocations offers provide exactly the same information to the customers, the location information of a message. So meaning longitude, latitude, and radius. Regarding Atlas Native, so as explained, Atlas Native is solely based on the Sigfox network. So this technology, this, I would say, method has been built by Sigfox and is a proprietary calculation made based on metadata provided by the devices and the base stations, Sigfox base stations. I won't enter into the technical detail here because Olivier Isson will explain how actually it works. The advantage, the pros of Atlas Native is actually to provide a geolocation everywhere. So the service is globally available. So as soon as you have a Sigfox coverage, you can have Atlas Native. It's everywhere. The very good advantage also of this service is it doesn't have any impact on the device. Any Sigfox device can actually provide Atlas Native. It's a very low-cost geolocation service also, and it's based on the existing Sigfox network, so you don't need to add an infrastructure to get geographic coordinates. And last but not least on the pros, it doesn't have any impact on the battery life because you don't need to add any component on the device. Regarding the cons, because of course there is also disadvantage on this service, well, due to the characteristic of our network, it provides a low accuracy. So we can improve it. So I will let Olivier Isson explain that, but more or less we say that we have an accuracy in kilometers depending on the Sigfox coverage and the environment in a territory. So how you can use it? Well, Atlas Native, it's a geolocation service, which actually is quite fit to asset inventory use case. So when you need to know where are your devices, once a month, once every 2 weeks, and you don't actually need a very precise geolocation, Atlas Native really fits to this kind of use case. It also is a good fit as a backup for GPS and Wi-Fi location. So GPS, as you know, doesn't work very well indoor, so Atlas Native can provide a backup in some cases. Regarding Atlas Wi-Fi, so it's the combination of Wi-Fi positioning and the Sigfox network location. It provides a good indoor and outdoor accuracy, so we can go down to 50 meters. And on average, we have between 50 to 150 meters of accuracy in urban and industrial areas. Regarding the price, it's also a low-cost geolocation service. Well, Atlas Wi-Fi, compared to main competitors, and especially Google, we provide a very low-cost service and with the pricing based on the device and not on the message, which is a complete different model. The service is also based on existing infrastructure. The Wi-Fi, it's based on a public hotspot and on public information that can be gathered by big players such as Google and here, which is our provider. And it's also global, such as Atlas Native, because thanks to Atlas Native, we have the fallback on the Sigfox network location. So when you don't reach, when the device doesn't get any MAC address, which is the ID of the Wi-Fi hotspot, it can fall back on Atlas Native. Regarding the cons, where compared to Atlas Native, you need a Wi-Fi module inside the device, which actually has a cost. And last but not least, regarding the application fields, well, it's very useful and it's very used already on asset tracking use cases, where you need a quite good solution, but not quite expensive for some use cases. So in supply chain and logistics, shipping and packaging services, and consumer goods. Last but not least, regarding Atlas Bubble. So Atlas Bubble is based on the Bubble infrastructure, which is currently under pilot at Sigfox with a Sigfox customer. We are testing this infrastructure, and this infrastructure will provide also a geolocation service on top of the infrastructure. Compared to Atlas Wi-Fi, it provides a very good indoor accuracy. So actually the principle is the beaconing. So it's a beaconing function, and you can configure it from 1 to 10 meters to reach 1 to 10 meters of accuracy. The pros is that compared to other similar technologies, it doesn't have any cost impact on the device, and you don't need to install a very expensive infrastructure. So you need an infrastructure, but it's low cost compared to RFID and Bluetooth. It's also global, thanks to the fallback on the Sigfox network location. On the cons, however, even if the infrastructure is cheaper than RFID and Bluetooth, you still have to install it and maintain an infrastructure. Regarding the application fields, asset tracking, it's also suitable for asset tracking use cases with similar use cases than Atlas Wi-Fi, but where you need actually a very accurate position of your assets, and specifically in indoor areas. So it can be indoor private areas such as factories, and it can be indoor public areas such as airports, for example. So basically how to use Atlas before going in depth on how it works. So the first step is to design and choose the right device. So before that, you need to actually identify the right technologies for the use case. So it's not the technology which is driving the use case, but the customer need who is driving the location technologies that you have to choose. The GPS is not the only one technology, as you saw. There's also the Wi-Fi, Bluetooth, Sigfox network, and all of the technologies that are going, such as the bubble. As soon as you selected the right technology, depending on the use case, you design or you choose the device which is compatible with this technology. Regarding Atlas Wi-Fi, we provide guidelines to integrate properly the service and to actually choose the right Wi-Fi module to make the service efficient. Regarding Atlas Native, there is no prerequisite because there is no impact on the device at all. As soon as you design the device, you can activate Atlas on your contract. And for this, you need to contact your account manager at Sigfox or your Sigfox operator to activate it on your connectivity contract. There is no configuration needed anymore on the backend, as the new data at the end callback includes the geolocation information. So now I let Olivier Hisson for the last part of the webinar.
Yes, hello, thank you, Andrea. So now I will talk about our technical solutions we have developed for network-based geolocation. So let me give you some details about that. So next slide. Okay, so network-based geolocation, what it is? It's simply the fact to be able to estimate a position using only the received message. So imagine that you have a device, which is represented here in the figure. A device is sending a message, and this message is received by several base stations in the network. And the goal of the network-based geolocation would be to use all the data we can collect using the received message to estimate a position. So typically, the data will be which base station received the message, what is the location of each base station, what is the signal level received by each base station. So basically, all the metadata we can collect, we will use them to estimate a geolocation position. So typically in Sigfox, we have developed two main techniques for network-based geolocation, and I will now briefly present these two techniques. So the first one is in the next slide, is the one we are using for AtlasNative. So AtlasNative is the service which is available since more than 2 years now. And for this kind of techniques, we are using a probabilistic approach. What does it mean? It means that we have developed a function which answers the question, what is the most probable area, knowing the metadata. So this function is a global function that we need to compute only one time, and the strength of it is that it is available everywhere in every country in the world. So anytime we receive a message in the network, then we can use this function to estimate a position associated to the message. And so I will not enter into detail for this function, but one thing to mention also is that we are also using machine learning approach to refine the model. So machine learning, I will give you some details after this slide to briefly present what we are calling machine learning in this area. But to use machine learning, we will need extra data, which are not necessarily available everywhere. But if we have them, then it will refine the model and improve the performance of geolocation. So for the performance of geolocation, for AtlasNative, it's the precision. So what is the precision of our algorithm? So in practice, it is quite difficult to answer because it depends on many parameters. The first one is the base station density. So if it depends also on the type of environment, so on the signal level, etc. But what we can say is that in average, globally, it's several kilometers in the world. And if we take, for example, so the big cities in France where the network is really well deployed, we have an average of 2 kilometers for the precision. So that means that the geolocation we are computing will be close to the device with a precision of 2 kilometers. So the second big technique we are developing for network-based geolocation is a full machine learning approach. So now I will try to give you an idea of what is full machine learning approach for geolocation. So the general concept of machine learning is for geolocation will be to construct a general function based on a lot of examples, and this function will try to associate a position with a Sigfox message as an input. So if we manage to construct this global function, then we will have for each received message each metadata corresponding to this Sigfox message. We will have a function that will give you the position associated to this Sigfox message. So to construct this global function, the machine learning will learn with a lot of examples. And for us, what are the examples? It's what we call geolocated messages. So typically, an example will be a couple of received message and position. So imagine you have a GPS device, then you will be able to know the exact position of this device, and in the same time we will be able to know the metadata associated to a received message. So really using all this received message associated to a position, we will feed the machine learning algorithms with this example, and at the end we will have this global function that will be estimated with this training set. And once we have the global function, then for any new message received in the network, then we will put this all the metadata associated to this message as an input of this global function, and then the global function, the machine learning function, will give as an output the position, simply the position. So for this kind of algorithms, we have already developed. The precision is really has very good enhancement because when we do some tests, we find that the precision is about hundreds of meters, so really lower, much lower than 1 kilometer, which corresponds to a lot of expectation we have from customers. So I think that's it's the end of the presentation now.
Thank you, Andrea. Thank you, Andrea and Olivier, for the presentation. Just for those who join us during the presentation, Andrea is a product marketing manager in charge of the geolocation services, and Olivier Isson is the head of data science, who designed the algorithm behind the geolocation services. So we'll have now question and answer session. So feel free to ask any question. You have two ways to do that. You can either raise your hand, or you can add your question in the little channel, and I will give you the mic. So we have a first question of Luc Vicas. I unmute your mic. You can ask your question.
It depends on what it's for. Yeah.
I just want to know if we can get this deck.
Oh, yes. So I'm going to answer. Yes, of course, we are going to share the presentation with you at the end, and you'll receive it by email, of course. We have another question. Anyone have any other question? Okay, so we have a new question from Edison. I would like to know if you are going to make a webinar regarding the API v2. So for those who want to have access to the agenda, you will find the whole next webinar on the website. We'll also share with you the agenda of the next webinar by email. A new question from Gildas. Okay, Gilda, I will unmute your mic. Sorry. Here you go. You can ask your question, Gilda. Thank you.
Hey, hello everyone. Yeah, so probably some of you know me, but I'm working for Sigfox in Switzerland, and like we see that the Sigfox Geolocation Services is quite lost around the Le Mans Lake, for example, because so the signal reflects to the water, and so as you know, maybe the lake is like half Swiss, half French, and like every time when I'm in Switzerland, the Sigfox geolocation give me a position in France, and the other side it's the same. So I just wanted to know if there is plan to work around this water effect. Thanks.
Yes, maybe I can answer you because yeah, of course we know this issue, and you perfectly summary what is the problem. So we have a problem due to the propagation near the seas, near lakes, so in coast area, because okay, the propagation is very, very good, and sometimes we receive the signal in some place quite far from the device, because the propagation in the sea or in the lake is very, very good. So to do something to improve the precision in this kind of area, we have several actions. So the first one for Atlas Native is to recognize, to try to recognize that we have this kind of issue. In practice, it's quite difficult because sometimes you are received only by one base station, which is very far from the device and maybe on the other side of the lake. So it's quite difficult. But what we can do is to learn that we have a high probability that there will be an issue. So in that case, what we are doing is trying to play on the radius. So for Atlas Native, for example, okay, we know that from time to time, we will have these kind of issues. And the best we can do is to say, okay, we have a position, but we think that we have a risk. And try to estimate the risk and to give a radius which is larger than what we can think at the beginning. So typically, the first thing is play on the radius just to make a warning that we have a high risk that the position will have an important error. So it's the first thing. So to do that, we have to learn with environmental data. So typically, when you know that you are near the coast, you know that you will estimate the risk to have a high error, etc., etc. So we have already some techniques to do that, and we are trying to improve the radius for this kind of messages. And the second thing is really using machine learning for the position. So typically, when you use machine learning, you will learn really the position when you have this kind of message. And the machine learning techniques will also learn that you have a potential problem. Why? Because if in the past you already observed this kind of issues, then the algorithm will take into account and try to give the best position, or maybe sometime you have a very high uncertainty, and so the algorithm in some cases will say, really, I don't know, so what the best I can do is put something in the most probable area and with a very high radius. So it's really the combination of these two things, play on the radius and play on the positioning algorithm with machine learning. I hope it was.
Yeah, okay. Thank you very much, Olivier.
Okay, thank you, Olivier. We have another question from Salvador Elche. So I will unmute your mic. Regarding the launch, related to the launch of the satellite. You can speak now, Salvador. Thank
you. You look like an idiot. Hi, I wonder if you have any news regarding when Sigfox goes satellite, what kind of precision will Atlas have at that time?
So just to answer part of the question, the satellite will provide an extension of the coverage. It's not another mean like GPS to have another type of geolocation service. So it's an extension of the coverage. I don't know if Olivier has something to say on how it can be computed for Atlas, because personally I have no idea since we haven't made tests, but maybe Olivier has some.
Yeah, so typically in the first step, the satellite will not be used for geolocation. And of course, it's something we want to add. But with the kind of techniques we are using and the kind of propagation we will have, in the first step, the geolocation given using satellite will certainly have a very rough precision, because it will not be using the same techniques as GPS, due to the type of signal which are using by Sigfox, so the ultra narrowband signals typically, and so I don't know exactly when it will be launched, when it will be used, but for sure with the first test with satellite, at the beginning, there will not be, we will not have some geolocation services. It will come in the second step.
Regarding the launch, we have a pilot at the second half of this year, and probably next year for the launch in beta or small offers coming. And then we will figure out how we can compute something, as said Olivier.
Okay, thank you. So the next question is from Kagiso Modise. It's about how much local data does the machine learning require to get to the inferior 1 kilometer. So I will give the mic to Kagiso, maybe to explain his question. Oh, sorry. So here you go. I think that this participant doesn't have a mic, so I will repeat the question for you. So the question was, how much local data does the machine learning require to get to the inferior 1 kilometer?
Yeah, so typically it depends on, again, many parameters, but we can give a rough idea. The rough idea is more than 1,000 messages by square kilometers to reach this precision, which is less than 1 kilometer. So typically, it's if we want to cover a very huge area, it will require really millions, in some cases billions of data. But really, with machine learning, what we see in practice is that in most use cases, it's really focused in some area, in some warehouse, some specific area, and for those kind of area, it's not so complicated to reach thousands of messages. But it's true that to cover an area, we don't need only one message, because we need a diversity in terms of messages, and that's why we really need some thousands of messages by square kilometer. Sorry.
Okay, thank you, Olivier. We have a last question from Kashyap Raval. It's about I don't know if you can answer this one. It's about Sigfox plan to expand in India. So if you got any question, any information related to this topic, that of course are not confidential, maybe you can share with us. Otherwise, I will try to give you more information afterwards.
Yes, no, we are not the right person to answer these questions.
Okay, so maybe I will introduce, I'll write your name, I will introduce you to the right person in charge of this topic. Have you got any other question? You can still add your question in the question channel, or you can either raise your hand and I will give you the mic. Okay, so I think that everything was clear for everyone. So thanks again for being part of this webinar. Thank you to Andrea and Olivier for this presentation. We'll send you, as already said, we'll send you the slide in an email and a recap of the presentation. And we follow our activities regarding the next we'll send you the agenda of the next webinars. And thanks again. Goodbye.
Thank you. Bye-bye.
Thank you. Bye.